Thank you, and good morning, good evening, good afternoon, depending on where you are. Thanks for joining this introduction to hybrid cloud on AWS. So we're going to get right into things, and we're going to have three learning objectives in this session. And the first one is to understand the hybrid architecture use cases. We're obviously not going to have time to cover all of the use cases. We're going to cover the key hybrid cloud use cases. We are going to understand the AWS portfolio of services and offerings and capabilities that help support hybrid cloud. And we're also going to talk a little bit about the partnerships we have with VMware, which has VMware Cloud on AWS, Microsoft, and other key enterprise players. To start off, first, let's talk about hybrid cloud strategy and what's happening with customers and with enterprise customers. And IDC has done a report, and the good thing is 83% of workloads are virtualized today. Obviously, a lot of those are on premise, and even though they're virtualized, what IDC found is that fewer than most of these servers are not being used at capacity. So there's fewer than they're used at around less than 20% capacity. So there's still a lot of capacity to be gained. Secondly, is that 60% of large enterprises run VMware VMs in the public cloud. So they're actually running already in the public cloud. And lastly, and why we're here today, is 65% of these organizations have a hybrid cloud strategy as of today. So these customers that are moving to cloud and have a hybrid cloud strategy, what is their thought process? What do they want around hybrid cloud? Well, first off, there is a lot of legacy data out there. There's a lot of legacy applications. In fact, some of these enterprise customers are still running things like mainframe computers. So they're going to need to continue to run these for the foreseeable future. So these systems are still going to be running. The second thing is obviously they want to run in the public cloud. They want to run on AWS, and they want tight integration because they're going to be running on-prem. They're going to be running on AWS. So they want tight integration, and tight integration specifically around security, networking, databases, applications, and we're going to talk about that today. And they also want to do it without purchasing new hardware or building new data centers. The CEO, Charles Phillips of Infor, is quoted as saying, "Friends don't let friends build data centers." So pretty appropriate in today's world. The hybrid use cases that we're going to discuss today is integrated identity and access, so security. So how is that integrated across AWS and on-prem? Integrated networking, and to me, the first two of these are the foundational aspects of any hybrid cloud environment. So no matter what you're doing in hybrid cloud, you'll be looking at integrated security and integrated networking. The third use case is data integration, and that goes a lot to business continuity and what some people call disaster recovery. The fourth component is integrated resources and deployment management. So how can you operate and manage across both on-prem and AWS using some of the same tools, and also how you can do development, application, and what people refer to as DevOps across both on-prem and AWS. The other area we're going to be talking about is integrated devices and edge systems. So this has a lot of focus on IoT, the Internet of Things, and we're going to talk about some services there that AWS has. The other item is cloud bursting, and the cloud bursting has been around for a long time, and people have really talked about how you can burst into something like the cloud where capacity is on demand and you can scale up as you need it. And cloud bursting is a big use case for hybrid cloud. And lastly, how you can extend in from on-premise into AWS, so for your data center, and maybe extend your applications, maybe extend your database, or maybe extend your entire set of applications. So just a little bit of level setting in terms of some of the AWS services. And in this session, we assume that you're going to have some knowledge of cloud, and you're also going to have some background knowledge of AWS and some of the services we have. And that being said, you can see some of the standard services that you should be familiar with, which is the virtual private cloud VPC, our IAM, our Identity and Access Management, Direct Connect for networking, EC2 for compute, storage gateway to expand your files and your block storage into the cloud. So we'll be covering these services during this session. The other thing that'll be covered, in fact, we have a couple of use cases and a couple of customer case studies around VMware and SAP, and we'll be covering how you can run Microsoft technologies on AWS in a hybrid situation. So firstly, let's cover a little bit about what we have in terms of regions, because obviously if you're going to be running in a hybrid scenario, you have to understand where the AWS regions are that you're going to be integrating in with, and perhaps look at a data center, one of your data centers that are closest to one of these regions to give you that low latency environment. So if you take a look at AWS and where we came from, is in the first 5 years of AWS, we deployed 4 regions. So we had 4 regions in our first 5 years. In the last 3 years, there's been 11 new regions. So you can see that there's been really an explosion of the number of regions globally, and you can see how these regions are across the globe, including in China and in Europe, and in Sweden and Frankfurt, and the US. Ohio is a fairly recent region, and then in Canada we have something in Montreal. The big red sort of yellowish background ones are actually not regions that are up and running right now, but are ones that are coming very soon, and those include regions in Paris, Bahrain, and Hong Kong, as well as another GovCloud region in the US East. The other thing to keep in mind in this picture is that AWS has a new a feature of Direct Connect called Direct Connect Gateways. And what that allows you to do is have private links between these various AWS regions. So it gives you that low latency network using the AWS Global Network Backbone. As I mentioned, what we're going to talk about next is the foundation of any hybrid cloud environment. And this includes the integration of on-premise identity and access management with AWS, and the integrated networking between on-prem and AWS. So those folks that have used AWS and is the virtual private network is through the virtual private cloud. And so what this does is give you a private IP address space and a private cloud within AWS. And across our individual AZs, which are in one region, so say US East region, you have multiple availability zones, which you could think of as like data centers. And you create a virtual private cloud, which has its own address space that you can access from your data center or from the internet. And then you can have subnets, which are either public or private, that reside in a specific availability zone. So one VPC resides across multiple availability zones to give you that high availability, compute resilience, as well as scalability. And you can have public and private subnets across that VPC. The other aspect is IAM Identities. So this is identity and access management. So it provides you with both authentication and authorization. So the first thing you want to do is create IAM users. So these are users that you assign passwords to, and you can use MFA, so multi-factor authentication, in order for these users to gain access through the AWS console. And you can also provide the users access keys and secret keys, And these are more for developers and third parties that are going to be accessing AWS through APIs, through our web services, through SDKs, and through programmatic interfaces. So you set up users in order to get into the console and in order to access programmatically through applications into AWS. And then what you can do is, obviously for developers, you might want to have a developer group and they would have access keys. They might not have passwords into the console. And you can also assign groups like finance or even a testing group, or for different projects you can assign groups. So as you can imagine, that if you're operating in a corporate environment with hundreds or potentially thousands of users, you may not want to set up all of these IAM users, because now you're looking at tens of thousands or potentially hundreds of thousands of users that you're going to be creating. And in the enterprise, a lot of people are using Microsoft Active Directory. So we have the capability in order to do the authentication against Microsoft Active Directory using SAML, so authentication. And then in order to authorize you, you make a call to a security token service as part of AWS, which gives that user temporary credentials based on what they're allowed to access for anywhere from minutes to hours to days in order to then get access. So this prevents you from having to set up all these hundreds of thousands of IAM users in your corporate network and leverage the existing LDAP server that you have, which is Microsoft Active Directory. The other component to it is, say if you're not inside of a corporation, but you have a mobile app, right? And this mobile app is accessing AWS services. You can use OpenID in order to do the same type of authentication and then get the temporary token with the access key so that this user gets authenticated against OpenID. That would be something like Facebook or Google or even Amazon. And then this mobile user could then get their temporary credentials to access whatever AWS resources they have the privilege to access. So in terms of I'm going to dive down a little bit into Microsoft Active Directory, because like I said, it's a big component of what a lot of enterprise customers are using. And so there's three different ways that you can sort of integrate and deploy Active Directory. And one of them is you can run Active Directory on-prem and then use a Active Directory connector, which runs on AWS, that would then delegate, if you will, or connect that user back to the Active Directory on-prem in order to do that authentication. The second thing you can do is you could actually stand up your own Active Directory on AWS. And AWS has something called quick starts. And what a quick start is, it's a template that includes all of the AWS services you're going to need to run. It includes your networking, your VPC, everything that you need to do essentially one-click deployment of a piece of software. In this case, it would be Microsoft Active Directory, and you can deploy that on AWS EC2. And it takes care of the infrastructure as code through a CloudFormation template that deploys all the necessary components that you'll need in order to run that Active Directory on AWS. The other offering we have, which was announced last year, is actually a managed Active Directory. So instead of you standing it up on EC2 and manage the high availability, the clustering, and patching and managing that Active Directory, is that we have a AWS directory service for Microsoft Active Directory that we manage for you. In terms of connectivity options, The first one is public internet access. So this is where, remember when I talked about these EC2 instances and having these VPCs and these subnets. So in this case, it would reside in what we call a public subnet. So these instances, these compute instances would have public IPs and would be directly accessible over the internet. And they can have public IPs assigned by AWS. And they're assigned specifically to that instance, or you can do what's called elastic IPs, where you can move that IP address around to different compute. But you have to remember that these instances then are then accessible, to the internet, and you need to make sure that you lock them down so people can't get access to them. The other option is to run VPN. So you're running over the internet still, but you're using a virtual private network using an IPsec tunnel in order to secure that connection over the internet. So you have a secure connection between your data center and AWS using a VPN connection. And here there's two options. You can use AWS Managed VPN, which has a customer gateway and a gateway on the AWS side to manage that IPsec tunnel. Or you can run third-party software such as Cisco CSR, or even like an OpenVPN, and then you would manage that yourself. If you're running like a Cisco CSR, we have something called the AWS Marketplace, which has prepackaged Cisco CSR that you can deploy through a couple clicks onto AWS. And then the last option, so a lot of people start off with the VPN option, right? They don't have a lot of bandwidth needs. They don't need a sort of a reliable connection in terms of speed. But if you're looking for a high-speed dedicated connection, you can get up to 10 gigabits per second through what's called Direct Connect. So that provides you that low latency connection right into AWS from your data center. So let's get into the use cases. The first of these use cases is data integration. And data integration is a lot about using AWS storage services in order to integrate on-premise storage with AWS. And when people think of data integration, they also think of business continuity or DR. The first scenario in a disaster recovery is common use case, cold standby. So what a cold standby means is that you're running on premise and you have your data on premise backed up into AWS, but nothing is running on AWS. So essentially everything is active on premise, but nothing's running on AWS. So in this case, you can use our AWS storage gateway, and you can use a file gateway, which is a way to move, just as the service indicates, it's a way to move files. So like documents, pictures, images, video from your on-prem. So you install this virtual appliance on-premise, this gateway appliance, and it automatically takes snapshots of those files and stores them onto S3 within AWS, and then you can back them up for long-term storage into Glacier. The other thing that you can do for more of like a database, say a relational database, a SQL Server database, is you can use a cached volume. So it's a different type of storage gateway, which actually takes those blocks and stores them and snapshots them into S3. So then what you can do, obviously, if you have this this information stored in S3 in a snapshot, is that you can, if you have a disaster, you can instantiate those EBS snapshots into running EBS volumes and attach them to EC2 instances in order to then have your application, your system up and running on AWS in the event of a failure on your on-prem. Now, in terms of the application, if you look towards the bottom of the slide, you have the Amazon machine image. So what you can do is to use the AWS import export in order to create a snapshot of that virtual image on-prem and then store it in S3. And then once you have that virtual image stored as an Amazon machine image, you can then instantiate it as an EC2 instance on S3. So then you can have your application up and running along with your data, and then switch over to AWS. The other scenario, and obviously cold standby is a very economical solution, but in the event that you need immediate RTO and RPO, so you need a really recovery time objective, which is very small, and a recovery point objective, which means that you don't lose any transactions at all, is you would use a hot standby. And so what you can do in this case is you use Route 353, which is a DNS server with a DNS failover and DNS weighted in order to fail over. So the DNS, what it will do is that you can have health checks on your load balancer or your proxy server on-prem. So you have health checks on the AWS side, and you're running across both environments, right? So this is an active environment, but you're probably weighted, using the DNS weighting, you're probably weighted more towards your on-prem because that's your primary site. But then obviously once the failover is recognized, DNS will fail over and everything will then be pointed and running towards your AWS environment. In terms of the application in the database, you're going to need to replicate this, right? And this is going to need to be some high-speed replication. You're probably going to use a direct connect, a dedicated connection, and you're gonna do the application. You could use something really simple and out of the box like rsync in order to sync those changes from the application over to AWS. And the database side, you have different options that you can use. You could even use Oracle Golden Gate because they have built-in replication features in Oracle. You can use a tool from AWS called the Database Migration Service, or DMS, which provides change data capabilities. On both the application and the database side, there's also third parties such as Cloud Endure, which do the replication between the two. With the announcement of VMware Cloud on AWS, there is a disaster recovery. So say in the event that you're running a VMware on-premise, you can use the VMware vSphere Site Recovery Manager in order to do disaster recovery. So this solution from VMware takes care of all the management, all the failover, anything that you need to do. So like I just described in the other two scenarios, there's other tools, other products, things that you needed to utilize in order to do the DR. With the DR as a service with site recovery for VMware, you can do this all through the VMware Site Recovery. So it gives you a very good option if you're running VMware on-prem to utilize the VMware Cloud on AWS offering with the Site Recovery Manager to provide disaster recovery. In fact, Scripps Network, which is a cooking food channel, travel channel, is utilizing this solution in a pilot light. So we haven't talked about pilot light, but pilot light's basically where you have a reduced footprint running on AWS. So Scripps Networks wanted a more scalable and reliable DR solution. Sometimes DR solutions can be very costly to implement, run, and test and manage. And in using the solution from VMware, they're able to have a low recovery time objective and no changes to the IPs, so you can automatically fail over into AWS. And there's a link if you want to take a look at the video that describes this in more detail. The next thing is integrated resources deployment management, and this is all around having automated maintenance and deployment across your compute, which is Amazon EC2, and your compute, which is either your virtualized or physical instances running on premise, as well as we'll talk a little bit about DevOps and microservices. So Amazon EC2 Systems Manager is a solution from AWS, which gives you the ability to monitor, troubleshoot, and take actions on groups of resources. And these resources can be located on Amazon with EC2, or they can be located on-prem. So you can use the same tool to manage both these resources. So what can you do with that? Well, you can automatically apply patches and updates, configuration changes. You can ensure that there's consistent configurations across all these, right? All these instances. So, you know, if you have firewall policies, you have antivirus definitions or software running, you can manage that seamlessly using the EC2 Systems Manager for your instances. So it allows you to really support a fleet of compute across both on-prem and AWS, and ensuring that all these instances are utilizing and leverage the latest updates, patches, and configurations. The other option for supporting servers running across on-premise and on AWS is a solution from AWS called OpsWorks. And OpsWorks is a configuration and management server that supports both Chef and Puppet. And Chef and Puppet are automated platforms that allows you to use code to automate your deployments of your application, including any types of application servers, web servers that you have. So it automates the deployment of application code along with all the components from your application. So the nice things about OpsWorks is that it supports servers both running on EC2 as well as running on-prem. So if you're a Chef or Puppet shop, which a lot of enterprises are adopting Chef and Puppet, you can use OpsWorks to manage and deploy those applications across your hybrid environment. The next option in terms of applications and doing a hybrid scenario with applications is microservices becoming very popular with the enterprise. So microservices are just small little pieces of code that are loosely coupled applications. So traditionally enterprises have had, you know, very large monolithic applications, and now they're breaking these down into small little components, which are called microservices. And Kubernetes is a platform which allows you to automate the deployment, scale, and management of these containerized microservices. So Kubernetes is a popular platform on-premise, and as of reInvent just this last year, so last November 2017, we announced Kubernetes as a service on AWS. So if you're running on Kubernetes on-prem, those same microservices, that same deployment can be deployed into AWS using the managed Kubernetes environment on AWS. So you don't have to worry about rewriting anything, changing anything. That same Kubernetes microservices deployment will easily run on AWS as well. And DevOps, you know, microservices are really popular. DevOps is a very popular way of deploying systems through coordinated effort between the development team and the operations team, right? So AWS has some services around their code pipeline, which actually manages that entire end-to-end all the way from the storage of your application using something called code commit, which allows you to host your applications in a GitHub repository, and then AWS Code Build, which builds your code, and then third, it integrates code pipeline integrates with third-party testing tools such as Jenkins in order to do automated testing, and then Code Deploy allows you to deploy both to EC2 or on-prem. So the great thing about this is that in this code pipeline, a lot of people talk about, you know, I'm going to do test dev on AWS and then, you know, maybe run on-prem, or I'm not sure. But in this scenario, you don't have to sort of decide. I mean, you can do all of your testing and development and building on AWS, so a low-cost, scalable capacity on demand, don't have to worry about buying any more compute. So you can do all that on AWS, and then at the end decide, well, I want to deploy this to, I'm going to just deploy this on-prem, or I'm going to deploy it to EC2. The next thing I want to talk about is, in terms of hybrid architecture, and I mentioned at the beginning, is this whole IoT, Internet of Things, and edge computing, which is really taking off in the enterprise and across companies, is being able to do edge compute and take advantage of the Internet of Things. So the first thing is Snowball Edge, and for those that have been around AWS for a little bit, they have heard of an appliance. It's a hardware appliance. You can see it up there in the right-hand corner. It's actually a physical device which has hard disks on it and has a Kindle embedded into it. And it was originally used, the Snowball was originally used for transferring up to 100 terabytes of storage to or data to AWS. So if you were going to, even on a direct connect connection, I mean, transferring 100 terabytes of information can take a considerable amount of time. So you would put your information on this device and then ship it to AWS, and we would load that into S3 or EBS volumes for you. Well, we had this interesting thought that, well, why don't we put some compute on this device? Because there's a lot of scenarios where people might, in the shipping, you know, if they're running a cruise airline, right, they might have a lot of information that they want to analyze or take a look at, and they don't want to send it up into the cloud, or don't have good access from a ship in order to send that information up to the cloud and do analytics on it. So why not do some of that offline data collection and analysis right on the ship? So you can do that with the Snowball Edge device. The Snowball Edge device can also act as like an IoT, an Internet of Things device, right? With windmills, that sensor data. You might not, I mean, there's lots of sensor data coming off of these windmills, right? A huge amount of data. So you might not want to either send all that data up into the cloud, or you might want to immediately react to that data, so you can send alerts based on the data that you gather in Snowball. Another use case for Snowball Edge is local tiering of compute at, say, a hospital, where you have medical images where you don't necessarily, you know, want to send them up to the cloud, or it's going to take a little bit of a while, and you need to immediately make a diagnosis for a person based on that MRI. So you could do that using the compute. And then the last one is a local transformation. So sort of acting, this Snowball Edge can act like as a extract in ETL, but not do any of the loading, obviously, at the edge, but do some of the data transformation, so you don't have to do the transformation in the cloud. Or maybe you don't, once again, maybe you don't want to send all the data, so you do some of the transformation or compression of the data and then send it up to the cloud. And this is more classic IoT. When you take it, think of the Internet of Things, you think of very small devices. You maybe think of, you know, sprinklers that, you know, have IP addresses that can integrate, you know, your cameras, security cameras at your home, your doorbell, your Echo device, that's your thermostat. So AWS has a service called Greengrass. So Greengrass is a piece of software that runs on local compute. It runs on any ARM device. So or it could run on a Raspberry Pi. A lot of people, you know, use Raspberry Pis for development in IoT. It could run on a Raspberry Pi or any ARM device. So Greengrass allows you to execute what's called Lambda functions. So it's an AWS serverless architecture. So you don't have any servers at all. It's just a small piece of code that's written in, say, Python or Java. And you can actually execute that on this IoT device in order to then, you know, interact with the cloud. The other thing, once you get that information in the cloud, then you can do AWS IoT analytics on that information. We have AWS IoT device management as well, because there's a lot of devices out there that need to be secured. So device to vendor allows you to secure those IoT devices as well. So of course, when you think about IoT, I mean, the one thing that the Internet of Things have done is explode the amount of data that's out there, right? I mean, traditionally people were sitting at a keyboard entering in data, and you can only enter in so much data as a human being, right? But now that machines are talking, cars are talking into the cloud, there's just a massive explosion of data, right? And so people want to do machine learning on that, but in some cases, you know, you might want to do some machine learning at the edge, but the challenge is that you need a massive amount of compute in order to do machine learning, and you need a massive amount of data. So that makes sense to do in the cloud, right? But with the Greengrass ML interface, you can do all that and create your logarithms, create the machine learning logarithms, and then push those down into to do the inference at the edge. So do all the heavy lifting, if you will, of machine learning in the cloud, but then push down the inferences down into those edge devices. So how is IoT edge computing being used in the real world? And John Deere is a great example of using AWS IoT. A couple of things that they have done, which you know, one of them is around planting seeds, and I know it doesn't sound like a very sophisticated thing to do, but you must be very precise on where you plant those seeds, how you know, how far apart the seeds are going to be, and you also want to be careful because, you know, seeds cost money. So they're using IoT inside of these inside of the tractors in order to be more effective when planting seeds. The other use case they have with IoT and combining machine learning, so another case where we're seeing IoT and machine learning being used, is to reduce or eliminate the amount of herbicides that are sprayed on the food we eat. I mean, we all know today, you know, concerns about, you know, the hormones and the pesticides that are in our food. So here's where John Deere is utilizing AWS IoT and machine learning in order to reduce or future eliminate. So cloud bursting, something that's been around for a while. So what cloud bursting means is you can take an existing application and that's running on your existing infrastructure, and if you need to scale it out, if you need, all of a sudden you need a massive amount of compute, and you know, obviously it's going to be difficult for you to go out and buy all this compute. You might even have to build more capacity in your data center. How are you going to do that? So you can burst that application into AWS. One of the fundamental pieces of bursting into AWS is EC2 Spot. So AWS has on-demand instances, which are charged by the hour. We have reserved instances where you do a little bit of upfront payment, where you get a reduced cost for doing an upfront payment of 1 year or 3 years. But Spot is spare compute capacity that AWS has. And because you are buying spare capacity, you can get discounts of up to 90% on AWS on-demand pricing, which is your pricing down to the second now. So you can use Spot in order to get this huge discount. And the reason it's so good for bursting is, the reason you're bursting is you're not going to use it, you know, for long periods of time. So the thing to keep in mind with Spot, and Spot has been around for a little while, is that in the past what happened is that If AWS needed that capacity or someone outbid you, there used to be a bidding, which is gone away, or someone outbid you on that price, you could lose that capacity. Well, there's two things that we've introduced, and one of them is a 2-minute warning, right? So this gives you an opportunity to then do something, right? So these are for workloads that can take some downtime, but the things that we've done recently, which is the 2-minute warning, and then you can also hibernate and stop and start these spot instances. So the need for, in the past where that spot was going to go away, you lost all the ephemeral storage that you had on that instance, and is now we have a 2-minute warning plus, and within that 2-minute warning, you can hibernate and keep that hibernated for as long as you want. You can pause that and then resume it later. So 2 new features that makes the spot a lot more attractive. So here's a customer success story around utilizing Spot to do cloud bursting, and this is from FuseFX. They have, if you take that link down there for YouTube, a great success story. Goes into a lot of detail on this use case, but essentially they needed to do bursting, because what FuseFX does is they do visual effects, a lot for TV, some for film, some for games, but they do a lot of TV, and so what was their option? Go out and buy more compute. They had limited power and cooling in their data center, so even if they could go out and buy more compute, the chances of it being able to run in their data center were limited. So they decided that they would use Spot, and in this slide, I'll show you a bit about the architecture that they used. And I think the big thing to point out here is a couple of big things. Is one, the network, right? I talked about AWS Direct Connect as being fundamental to any hybrid cloud scenario, right? And I also talked about storage being a big component of any hybrid cloud environment. So you'll see both of those here, right? So they're started off running things over the internet, but then quickly decided that using Direct Connect, giving them that low latency, high-speed connection was the best way to go. And then obviously they needed to synchronize their data sources because that data needed to move into AWS in order to run this Spot fleet, right? So they did Cumulo clustered file system on AWS and then synchronize that back into their on-premise environment. The last use case I'm going to talk about is data center extension. So this is where you might run a database on-premise or in an AWS Direct Connect location. You can run in one of our facilities that's co-located next to one of our AWS availability zones, or you could run that database on-prem. And the other scenarios are around applications running simultaneously on AWS and on-prem. So, and then the third example I'm going to show you is around extending compute to on-prem to AWS. So in this first example, we see you have an Oracle database, and in this case, this Oracle database may integrate in with a lot of other databases and applications, right? And so you can't necessarily, it's not very standalone, it's very tightly integrated with other applications, and you're thinking about moving to the cloud, you're gonna migrate to the cloud, but you're like, wow, this is so highly integrated, I can't really move it. But what I'm gonna do is I wanna move my, I'm gonna move my application. So my load balancing, my web server, my application server is all going to reside on AWS, but then my Oracle database may reside in a AWS Direct Connect facility or on-premise. And then, of course, in this case, you're not going to be running a VPN over the internet. You'd be running Direct Connect connection over to that Oracle database. The other scenario, which is a new scenario, is running your application across both on-prem and AWS. So you can use either what's called well, what used to be called the classic load balancer, which is now called the network load balancer, which is a TCP, HTTP load balancer, HTTP, HTTPS load balancer, which is the NLB, the network load balancer, or the application load balancers, which is a layer 7 aware load balancer. So it has some context about the application. And using that load balancer, you can direct that traffic to your web or application servers that are either running on-prem or on AWS. The other scenario is going back to VMware Cloud on AWS. I discussed the business continuity DR scenario where you can do DR in AWS using the VMware Cloud on AWS. This one is actually leveraging and extending into AWS. So what you see there on the right-hand side is AWS services. So if you're running VMware Cloud on AWS, you're running their software-defined networks and software-defined storage, and your virtualization with vSphere running on bare metal on AWS, right? But you can create an elastic network interface and actually start to utilize some of the services from AWS, like compute EC2, like S3, like RDS. So you, in essence, you have a hybrid cloud of hybrid cloud where you're running VMware on AWS, and then you're running native AWS services. And then you can also, which is a great thing for enterprises, is you can use a vCenter with a hybrid link mode in order to manage your environment on-prem, VMware on-prem, and use that same console to do all your management operations on AWS. And through vCenter as well, you can, it has an option to just say, migrate this VMware instance over to Amazon EC2. So it has a migration option built right into the vCenter tool. So I talked about Microsoft, but I have not mentioned SAP yet. And Intel, I mentioned Intel, and I obviously mentioned VMware several times, both in DR as well as in extending your data center. Intel, obviously, a lot of our EC2 instance types run on Intel processors. Here's a use case of SAP, and this is a hybrid cloud deployment where Kellogg's is actually doing their test dev on AWS. A lot of the production is still running on-prem, but what this allows them to do is time and stage the deployment to cloud, right? So they can take SAP HANA, run it on-prem, run test and dev, and then once they test enough on AWS, then simply switch over to production on AWS. Thing to point out here is you'll see the 244 gigabyte instance of memory types. Recently, last year, AWS actually announced the X1 instance type, which has up to 4 terabytes of memory. So you can actually have 4 terabyte memory instance types, which is obviously very, very good for HANA because it's an in-memory database and it requires a lot of memory. Well, thanks a lot for joining me. Hopefully these use cases were applicable to you all the way from disaster recovery to extending into the enterprise to doing edge computing, as well as doing system management and managing both EC2 and on-prem instances, and learned a little bit about OpsWorks and how you can do that and how you can do DevOps using code pipeline and code deploy in order to deploy on-premise in AWS. If you're interested in more information, there is a website that goes into a lot more detail about the things that I've covered in this discussion today, and that's at the top link, the hybrid cloud link. The second link goes into hybrid or enterprise, and you'll see success stories of hybrid cloud from companies like Comcast, Hess, Pacific Life, Johnson & Johnson, and other large enterprise companies. The third link goes into the cloud adoption framework. And so if you're embarking on your journey to cloud, the cloud adoption framework helps organizations understand where they are in their cloud journey and covers things from a business perspective, from a compliance perspective, and then from a technology and operations perspective as well. So it's a workshop that is delivered by AWS, and it gathers up people from both the business and technology side and helps you understand where you are in your cloud journey and helps you overcome some of the perceived challenges of moving to the cloud. The well-architected is a framework that covers security, cost optimization, resiliency, and takes a look at your workloads, right, and make sure that they utilize the best practices from AWS around security, around resiliency, around cost optimization, and around performance. So a well-architected program is something that's delivered by AWS solution architects and people in the field to help you utilize the best practices for being architected on AWS. And then the last program listed there is the Migration Acceleration Program, which is called MAP short, and that's a program that provides credits in training and the ability to get over what's called the migration hump. So there's going to be some initial costs in order to migrate, and the MAP program provides you some AWS service credits as well as training credits, and also help from AWS's professional services in order to execute on your cloud migration journey to AWS. Thanks again, and I appreciated spending time with you today.